Welcome to a journey into the invisible world, exploring the science of stopping time. We will descend through three barriers of perception: the macroscopic, the relativistic, and the quantum. To reveal the world's hidden mechanics, we need faster light, not faster eyes. In the 1920s, engineers struggled to diagnose fast-spinning electric motors using standard cameras. The movement resulted in useless blur. Harold "Doc" Edgerton's insight was that if you cannot make the shutter faster, you must make the darkness longer. Edgerton's solution involved leaving the camera shutter open in a pitch-black room. He then used a flash that lasted only 10 microseconds. In that brief window, the motor only completed a fraction of a rotation, appearing perfectly frozen on film. The light, not the camera, freezes time. This flash uses a capacitor to store high voltage. A trigger pulse ionizes the gas inside a glass tube. The stored charge releases, heating the gas instantly to create a blinding white light, then quickly restoring darkness. The light duration is just 10 microseconds. Synchronization is key. Since a bullet travels faster than sound, the sonic boom itself is used to trigger the flash. A microphone placed along the trajectory detects the sound wave, ensuring the brief flash captures the event precisely, avoiding ghost artifacts. Edgerton scaled this technique from capturing milk drops to aerial reconnaissance in World War II. He built a 60-megawatt strobe to photograph enemy movements at night, proving that whether capturing surface tension or a coastline, the physics remains. Overpower the sun, freeze the moment. There is a trade-off between spatial and temporal resolution. To achieve billions of frames per second, modern high-speed cameras must drastically reduce image size, creating a data readout bottleneck. To capture light itself, we need 1 trillion frames per second, which current sensors cannot physically handle. To film light traveling through a bottle, researchers used a camera that only sees 1 pixel. This mechanism, based on LiDAR/time of flight, counts individual photons. It captures data in bins, 1 picosecond long. In that time, light travels just 0.3 millimeters. The camera constructs the image 1 photon at a time. A laser pulse hits a point, and the sensor records the return time of the scattered photons. Mirrors then steer the view to the next point. By repeating this millions of times, a 4K video is mathematically reconstructed. The constraint of this technique is infinite repetition. The event must be perfectly repeatable. Since the camera scans 1 pixel at a time, the video is a composite of millions of separate laser pulses recorded over several minutes. Any variation would result in a garbled mess. Because the data is a 3D reconstruction, researchers can move the camera perspective in post-processing, creating, quote, fly-throughs. This relativistic effect makes wavefronts appear stationary or warped. We are navigating a dataset of light propagation, not just filming reality. To see the building blocks of matter, picoseconds are too slow. We need X-rays. The world's fastest strobe light is a 3.2-kilometer accelerator that drives electrons to 99.999992% the speed of light. This 3-kilometer strobe light generates pulses lasting about 100 attoseconds. For comparison, an attosecond is to a second what a second is to the age of the universe. Undulators force electrons to wiggle, emitting X-rays, which then microbunch to create a coherent X-ray-free electron laser. The pump probe method uses a laser pump to excite a molecule, starting a reaction. An X-ray probe hits the molecule, knocking out an electron. By measuring the kinetic energy of the ejected electron, scientists infer electron density. A stop-motion movie of the electron density is built by increasing the delay between the pump and probe. For the first time, we can validate our quantum calculations with direct observation. When theoretical simulation meets SLAC experimental data, it confirms our understanding of quantum mechanics. If you keep slowing down, you eventually see the machinery of the universe.